is OSI? OSI stands for Open Systems Interconnection.
The history of the OSI. So who developed the OSI? The OSI was developed by the ISO, or International Organization of Standardization, originally developed in 1977. OSI was created to standardize networking to enable everyone to be connected through a common network. So how can you remember the layers of the OSI? Just remember, please do not throw sausage pizza away. Physical, data link layer, network, transport, session, presentation, application.
Now let's look at the 7-layer OSI reference model.
Layer 1. The physical layer. The physical layer is one of the key components to the OSI reference model. The physical layer consists of all the actual hardware, such as cabling and network cards, displayed here. This layer sends the bit stream in the form of electrical impulses, using light, digital or radio signal. The main role to the physical layer within the OSI model is simply using the hardware to communicate devices over a network. The communication is done by binary transmission for sending and receiving data over the physical link. As you can see here, it is done by binary transmission using ones and zeros. Shown here is just a digital signal, and here is a radio signal. As you can see, it's a wavy compared to straight up or down for representing 0 and 1s. The protocols involved within the physical layer include hubs and repeaters, which are tied in within the physical layer. Layer 2, the data link layer. Data packets are encoded and decoded into bits. It supplies the transmission and protocol information management. This layer manages the errors from the physical layer using flow control and frame synchronization. The data link layer is divided into two separate sublayers, the media access control, or MAC layer, and the logical link control layer, LLC layer, shown here. The MAC sublayer controls how a computer on the network gains access to the data. The LLC layer controls frame synchronization, flow control, and error checking. The MAC address can be found quite easily using the command prompts in Windows, typing ipconfig/all, and then finding where it shows highlighted here, the physical address, or the MAC address, and this is just an identifier of the actual network card. It can also be on the network card itself, shown here. The communication for this layer is either point-to-point over either direct link or multi-point mediums. This ensures error checking and flow control from the physical layer is corrected within the data link layer, using Ethernet local area connections or wide area networks. The protocols involved within this layer include switches and bridges. Layer 3, the network layer. This layer consists of the switching and routing technologies, creating logical paths known as virtual circuits for transmitting data from node to node, as you can see here. The function of this layer is to deliver data selecting the best path possible. It's the management of delivering data from different locations to receive the fastest possible solution, which is commonly called routing. The protocols included within this layer are Internet Protocol, IP, and are often known as routers using IP version 4 or IP version 6, shown here. It also handles error checking, congestion control, and packet sequencing. Layer 4, the transport layer. The transport layer divides data from the main host to end systems, and this layer is responsible for end-to-end error recovery and flow control. This layer ensures complete data transfer, and it is required for reliable delivery of the files. The transport layer breaks down large files into smaller segments that are less likely to encounter delivery problems and is the boundary between application protocols and data flow protocols. Shown here, just a breaking down of the files sending to and from the transport layer. The transport layer provides a data transport service that protects the upper layers from transport implementation details.
Layer 5, the session layer. The session layer controls the connection between computers. It establishes, manages and terminates the connection between the local and remote application. The data from the application layer are not yet sent. First they need to know if the computers can communicate with each other. So at the session layer there is a protocol that establishes the connection, then manages the connection. The protocol is called Remote Procedure Call, RPC. What happens here is computer A says, I've got some information to send you. How fast can you receive this information? Computer B then says, I have this network interface card and it can go up to 100 megabits per second. Can you do that? Computer A then agrees or disagrees. Layer 5 doesn't require knowledge of the exact application. All it cares about is the data present to pass along down the channel. Layer 6, Presentation Layer. The name of this layer suggests its main function. It deals with the presentation of data. More specifically, the presentation layer is charged with taking care of any issues that might arise where data is sent from one system and needs to be viewed in a different way on another system. For example, if computer A doesn't code a file type, there will be no way for computer B to know how to display it. But if computer A codes a JPEG, then computer B will have no problem reading this file. Also, another function of the presentation layer is compression. If the protocol requires compression, then it is compressed. On the receiving side, if the package needs to be decompressed to be read, then that happens on the presentation layer. Some types of encryption and decryption are formed on the presentation layer. This ensures the security of the data as it travels. For example, one of the most popular encryption schemes that is usually associated with the presentation layer is the Secure Socket Layer protocol. Not all encryption is done on layer 6. Layer 7, the application layer. When a user sits down at a computer and runs an application of some kind, if the application is going to use the network, it employs layer 7 of the OSI model. The application layer is not the application itself doing the communication. Layer 7 makes sure that the other party is identified and can be reached. It also ensures the necessary communication resources exist. Some examples of simple protocols in the application layer are SMTP, stands for Simple Mail Transfer Protocol. This is generally used to send and receive messages. FTP, which is File Transfer Protocol, used for sending and receiving whole files. HTTP, Hypertext Protocol. This is used in every web browser for websites. This has been our video on the Osi reference model. I hope you find it useful. And remember, please do not throw sausage pizza away. Thank you for watching. Goodbye.